Welcome to the Chapter 3 podcast. This is the 3-1, and we're going to be talking about Newton's first law of motion, and this is one of my favorite cartoons. I love this one. So the big idea for this entire chapter is that forces cause changes in motion, and we've talked about forces causing motion, but we're going to be more specific and say they cause changes in motion. So let's look at, let's start with an example here. A ball at rest in the middle of a flat field is in equilibrium, so no net force acts on it. But if you saw it begin to move across the ground, you'd have to say that something moved it. There had to be a force. And our intuition is that we don't believe that changes in motion occur without a cause. There has to be some reason why it happens. So the ancients, ancient Greek scientists, so to speak, looked at motion and divided motion into two types of motion. They were looking for a cause. And the two types of motion were natural motion and violent motion. So we're talking about Aristotle, and his ideas of motion were very simple. He believed that motion on Earth, natural motion on Earth, was either straight up or straight down, and that things went to their natural resting place. In other words, boulders went to the ground and smoke went up in the air, because smoke looks like air and boulders look like the ground. And also, heavy things would fall and very light things would rise. And that circular motion was what things in the heavens did. For instance, planets went around in a circle. They're circular, so it makes sense. And these motions were considered natural. And here's the important point. They were not caused by forces. They just happened. Now, the second type of motion he talked about was violent motion, and this was imposed, meaning there had to be a force. It was a result of forces. And it had an external cause. It wasn't natural. And this is closer to what we now know. And it was violent motion was imparted to objects, and objects in their natural resting places could not move by themselves. They had to have a violent motion imparted on them. So Aristotle thought that in order for something to move, there had to be the presence of force. Now remember, I said something to move. That means that doesn't mean something to start moving. It means something to actually be moving. And we know that boulders do not move without a cause. So this went on for about 2,000 years. They thought that a force was responsible for an object to be moving against its nature. And the state of objects was at rest unless we were being pushed or pulled toward their natural resting place. This is a big one. Earth did not move. Earth was stationary, and everything moved around Earth. And Earth had to be in its natural resting place. It was the center of the universe. And the fact that a force that was big enough to move it was just unthinkable. So let's review here. According to Aristotle, what were the two types of motion? The two types of motion he studied were natural motion and violent motion. Now, because these sections are so short, let's go right on to 3.2. 3.2 is about a man named Copernicus, and he was a little more, had a little better idea of what was going on than Aristotle. He assumed that Earth and the other planets moved around the sun, and this was a radical idea. There's a picture of Copernicus, and he formulated his theory in the 15th century, between the 15th and 16th century. And here's a drawing roughly. Here's the sun, here's Mercury, and you notice all these. Here's the Earth's orbit right here in pink, and you notice that all the orbits are circular. This was extremely controversial at the time, because people wanted to think that the Earth was the center of the universe. and he worked on his ideas in secret, and he published them, and copy of his work reached him on the day of his death, ironically. So what did Copernicus state about Earth motion? And this is very important. He stated that he stated that the simplest way to interpret astronomical observations is that the Earth and other planets moved around the sun.